So section 6.3, we're actually going to work with modeling with polynomial functions. So just like we've done with exponentials, logarithmic, right? We get a data set, and then from that data set we have to decide which model is the best fit. So for polynomial regression, we go right into stat calc, where we used to find our linear regression. So we still have lin, but then you'll see there's quadratic, cubic, and quartic. And so this is what I was mentioning back in section 1, that you really need to know the names of these functions because that's how they're going to be indexed in the calculator. The coefficient of determination we've worked with in the past, right? R is the measure of explained variation in the model. R squared is, excuse me. And R squared is a percent given in decimal form. So it's always a number between 0 and 1. And 1 minus R squared is the percentage of unexplained error. So if 80% of the error is explained, then 20% of it is not. And the larger your R squared is, the better fit it is to the data. So what we want to do is we want to take this data set and we want to figure out which one of these would be the best model. And we can do that two different ways. We can compare their R squared score and we want the highest R squared, or we can look at the sum of the squared errors. So I'm going to show you a kind of efficient way to do this when you're storing the function, so you can fill this table out and not have to backtrack and do so much work over and over again. So the first thing that we're going to have to do is we're going to have to put this data in our list. So I'm going to go back to my calculator. First I'm going to go to y equals, and I'm going to clear everything out. Then I'm going to go to my lists, edit, and I'm going to clear these lists. All right, so good fresh start. So in L1, I'm going to enter these numbers. It's 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then in my y values, I'm going to enter the corresponding y coordinates. So 32.2, 201.4, 489.1, 1203.6, 1904.5, 2567.3, 2999.1, 2876.5, 2057.2, and 152.9. So 10 x values, 10 y values. So then I'm going to quit, okay, and I'm going to go to Stat, Calculate. And the first thing I see here is linear regression. So when I select linear regression, second one says the x values are here, right? Second two says the y values are there. And then I'm going to put another parentheses, and I'm going to go to vars function, and I'm going to tell it to store it in y1. So I'm picking y1 because that's what we always pick, but I'm specifically picking y1 in this case because a line is a degree 1. So that way I know that this function is in my y1 spot. So here's the equation. It's already popped the equation over for me later, but there is my r squared value. So my r squared value, and I'm going to take these out 2 decimal places, 0.25. So now I can very quickly grab all of these r values. So stat, calculate, just below linear regression is quadratic regression. Once again, L1, L2, but now I'm going to tell it to store this equation in function y2 because it's a degree 2 polynomial. And there's my ABC, and here is my r squared, 0.73. So I already know this model's getting better, right? Upping the degree. So now we can do it again. We're going to go to Stat, Calc, and just below quadratic is cubic. So L1, L2, oops. And now I'm going to store this one in, you guessed it, Y3. And there's my r squared of 0.996. And we'll do it one more time for the quartic function. So stat, calculate, quartic is next on our list. L1, L2, and then we'll put this guy in Y4. So I've got to scroll down here to see my r squared. There it is, and it's 0.999. Okay, so these are all my r squared values, so I can already see that the quartic function is best because it has the largest r squared, right? But now we need to look at their SSEs, because this is something you're going to be asked to do quite a bit. We never give this up. So let's go back and review, how do we find the SSEs for each of these? So this is where storing this function was really helpful. So if I go to list, edit, right? There are my X's and Y's, so we're going to do the line first. So in the line, the first thing we do is in L3 is I want to plug the X values into the model that I created. So I'm going to go to vars, and for the line I picked Y1. So I'm going to plug my L1 values into here. Then in L4, I'm going to find the error, or the difference. So I'm going to take the actual Y values of L2 and subtract the predicted values L3. And then in my last list, I'm going to square the error terms. Perfect. So if we quit and go back out to the main screen, I can go to stat, calculate, oops, sorry, second stat for list. So ops is where we found sequence, math is where we find sum. And so I'm going to sum up my squared errors. And I get 9378577.8. So really, really big sum of squared errors. Now I've got to go back to my list, edit, and I've got to clear L3, 4, and 5. So even though this is kind of a pain, we've actually set ourselves up to do this quite efficiently. So now I want to plug all these values into my quadratic. So I'm going to go to vars, and we are saved it in Y2. So we'll plug L1 into Y2. There we go. And now we'll get our error terms. And now we'll square them. Now what's great is when I second quit, if I don't clear this screen, all I have to do is hit second enter. It pulls right up the command. I don't have to go hunt for that every time. And now when I hit enter, there's my second value that I need. So 3, 3, 3, 9, 8, 8, 1.3. So then we're going to go back to list, edit, clear these guys again. And we're now going to plug them into Y3. So vars, oops, it's putting it in the wrong place. I want to do it for the whole list. There we go. Vars, function, Y3. Oh, I didn't like it. Let's check and make sure there's a function there. Oh, there's definitely one there. Let's try this again. So list, edit. All right, so my values are there. So let's try this again. So vars, function, y3 parentheses L1. Now it worked. So now let's get our error terms, L2 minus L3, and let's square them. So once again, all I got to do is second enter. There's my next one. All right, we get to do this one last time. So edit, clear this. All right, so now we go to vars. We grab y4, plug in L1. What is going on? Why doesn't it like it? Normally it just does it. I just want to make sure we did save the function. So let's try this again. So list, edit, there we go, vars, function, y4, L1, there we go, L2 minus L3, and square L4. So now, second enter, and boom. So now if we look at this, we can see that the sum of the squares errored got smaller, right? The error terms, that meant the model got better because we had less error. So it's also the best one because it has the smallest SSE. So there are two ways you can verify a model of best fit. You can look at its R squared, or you can look at its SSE. These two things should always give you the same answer. So the biggest R should correspond with the smallest SSE. So you may be asked to only do it this way, you may be asked to only do it this way, but I just showed you how you could do both, and by storing the functions and naming them appropriately, you can really reduce the work if you're more comfortable with one way over the other.